Hello everyone, welcome to this session on Introduction to DevOps. During this session, we will be going through what DevOps is and we will be understanding why it is used and basically how to basically implement it. All right. So this is the first class for our DevOps session. And this is basically a demo class for you guys, wherein you can understand if DevOps is your cup of tea or not. So let's go ahead and first look at what is the agenda of this session. So, guys, we are first going to understand what is software development because if we understand software development, only then it will make sense for us to understand DevOps. Right? So, we'll understand what software development is. We'll understand three different methodologies using which software is developed, basically, which is waterfall, then you have agile, and then you have the lean methodology. Right? So, these three are basically the most famous software development methodologies throughout time using which software was actually developed. After that, we're going to basically differentiate between the three, waterfall, agile, and lean. And then I'm going to introduce you to what is DevOps. Now, DevOps is also basically a methodology using which you can develop software. Now, the question which arises is that when we had three software development methodologies which claim themselves to be successful, why did we need DevOps as a separate methodology, right? So that is the question that we are going to answer. And once we have the answer for that, then I'm going to tell you how DevOps is basically implemented and what it is exactly. All right. So guys, this is the agenda for this session. I hope it's clear to you. Now let's move on and start off with the first topic, which is what is software development. So Amit says one question: is it for developers only? Not at all, Amit. DevOps has nothing related to developers. DevOps is basically a methodology which is developed for developers. So essentially, what happens is in a tech team there is only one or two DevOps engineers, and then there are multiple developers, right? So the DevOps engineers basically come up with a methodology. They come up with the they come up with a pipeline in which basically developers are a part of. In that pipeline, testers also come. In that pipeline, operations guys also come. DevOps is the person who basically tells them how to work, right, and basically sets the environment for them to so that they can work and their work can be accomplished using the DevOps methodology. And I think it will be more clear when we actually move along. Okay, all right, let's go ahead then. So what is software development exactly? Let's go ahead and understand that. So guys, software development is basically the process of basically converting customer requirements into a complete software product. Okay, now what do we mean by this? So let's look around. We have many websites, we have many applications around us. We have applications like Netflix, we have applications like Instagram, Facebook. Now think about the time when someone had an idea about creating these applications, right? And not necessarily everyone who basically is a founder of a particular application like Netflix or Facebook or Instagram is a developer, right? So what they do is they basically jot down their ideas and they then approach people. They either approach companies or they approach developers who can help them out in converting their ideas into an application, right? 90% of the times it's basically a company that you approach. For example, there are a lot of service-based companies such as TCS, such as Infosys. Now these companies, what they do is they basically develop softwares. And who approaches them? Some big banks, like any bank you name, they basically approach companies like TCS, Infosys, and they say, you know what, I want a platform wherein customers can probably join in, they can check their balance, they can download their statements, right? So all these softwares are not actually developed by the companies themselves, but they basically go to a service-based company like TCS, Infosys, and they say that, you know what, I want to go ahead and I want to get this product developed. Can you help me out with this? This is way number one. Way number two is that a company can have its own development team, right? They can have their own product team. And basically what they do is they hire the right people, and then that team basically develops their application. That is also one more methodology using which software is developed. Now, within this team or within this company, what happens is there is an architect who basically interacts with the customer who has this idea of creating an app. Let's say I have an idea of creating an application like Instagram, but I don't have any technical background. So what do? I basically, go ahead and approach, either if I'm the owner of my company, either I'll hire a person who's technical enough, or who's a technical architect, and I can go to him and tell him my ideas, and I tell him that, you know what, these are the features that I would want in my application, and now you go ahead and create this application for me. Now the game starts. Now this is the place wherein the architect has got all the ideas, he has got all the requirements for the application, and now he has to convert these requirements into an application. Now how is this done? This is done using software development methodologies. All right, now there are a lot of methodologies, and the first and foremost methodology which probably got the most recognition is called the waterfall methodology, right? So let's go ahead and understand what is waterfall methodology. But before we can do that, let me in general outline what software development is. So first, in software development, what happens is you basically go ahead and gather requirements, right? First stage is the requirement stage, and after the requirement stage, so this is the stage wherein the architect talks to the guy who wants to get the app developed, and he gathers the requirements. And once the requirements are gathered, next stage is basically the design stage, wherein the architect goes ahead and he designs the application based on the features which are required, right? Once the application is designed, they are basically so when I say designed, it is still on paper, it's still on board, right? So you design what all components of the application you have to develop, who will be doing what, right? So stuff like that. And then once this plan has been laid out, it is basically forwarded to the developers, and that is exactly what the implementation stage is, right? So once the plan has been given to the team starts working on it, and once the team has worked on it, it is then verified, which is the verification stage. And finally, once the application has been verified, it gets released to the customer releases its product to its stakeholders or to the people who are going to use their application. And then this company who developed the application starts the maintenance phase means that, let's say, you would have noticed that whenever there is a new let's say if you're using Windows 10, you will see every month there is a Windows update which basically has some security fixes, some bug fixes. Similarly, you would have seen that even in your Android or in your iPhone, you frequently get updates which are basically bug fixes, right? So these bug fixes are nothing but the maintenance phase of your application, wherein the application is now being maintained. It was developed earlier, every feature was offered, but now based on user feedback, one or two new features are being added, or the bugs which are identified while the users are using it and reporting it, those are basically fixed, right? So that is basically the maintenance phase. So these are the different stages that you have in the software development methodology. And now let's go ahead and let me walk you through what the different kind of methodologies which can be implemented to these life cycle stages, right? So there are three popular software development methodologies. The first one being the waterfall model, then you have something called as the agile model, and then you have something called as the lean model. Okay, what these models are we'll discuss in a bit, but these are basically frameworks, or these are basically a set of rules using which the stages that we just discussed, which is basically requirements, design, implementation, verification, and maintenance, they are basically implemented. Okay, you understood what we discussed so far? So what I've told you so far is that there is something called as a software development methodology, which is basically a methodology which is used to develop software. In that methodology, there are various stages, such as first stage is the requirement stage, where the requirements are gathered. Then comes design stage, where the manager basically plans how the application is going to be developed. And once the planning is done, it is basically distributed among the team, which is basically the implementation stage, right? The team gets it done. Then comes the verification stage where the application is tested. And finally comes the maintenance phase where you do the bug fixes. And this phase-wise development lifecycle can be implemented using various frameworks or various rules. Among those rules, we are going to discuss three today, which is basically waterfall, agile, and lean. All right, no questions. Let's go ahead then. So let's start with waterfall model. And what is waterfall model, and what basically is the difference between waterfall, agile, and lean? Okay, so guys, waterfall model basically means that these stages, the requirements, design, implementation, verification, and maintenance stages, these stages are implemented sequentially. What does that mean? That let's say I basically interact with the CEO of, let's say, Instagram, and this guy basically has told me that in Instagram I need 150 features. So what I do is I start working on those 150 features at once. I design the plan, and then I give it to my developers, and finally by the end of this maintenance or verification stage, I get the whole Instagram application with all the 150 features. This is the waterfall model. Why is it called waterfall? Because the method, the plan is going one way. So how you see waterfall? Waterfall basically is a unidirectional entity, right? It flows from one place, and it flows from point A to point B, right? It always goes down, it never comes up. That's what waterfall is, right? So similarly in this stage as well, once one stage is over, for example, let's say the customer came in, he told the architect the requirements. The architect, once he understood the requirements, that means that stage is now over. And now once he starts design stage, the requirement stage cannot become again, right? So in more practical sense, if I were to explain you can understand it like this: that let's say you as a customer go to a company and say, this is the software that I want to basically get developed, and you give them all the features, and let's say after 4 or 5 days, by discussing with your friends, you think, okay, there's one more feature which I think can be added to my application. You again go to the architect. The architect will say, you know what, we follow a waterfall model, we have already started the work, and we cannot accommodate any changes that you're saying. Okay, so this is what waterfall model is, which means if, let's say, in between while your software is being developed, if there is any kind of change which your customer is suggesting, you cannot incorporate it, because you're following the waterfall methodology, which basically means if you're done with one stage, you will never go back to that stage again. Okay, now this is very advantageous, and this obviously has disadvantages as well, right? And we're going to discuss that in a moment. So what are the disadvantages, or let's say what are the advantages in this case? So the advantages in this case is that each and every stage that you're completing, you're ensuring that it is completely aligning to what was discussed with the customer. Okay, so if we allow, let's say, the customer to tweak the features in between the life cycle, right, we will again have to go back to the whiteboard, again start doing it again, think about how we can plan it, and then give to our developer. So there is no tweaking allowed. Whatever has been locked once will be locked, and that is how the software will be developed. Now you might think, I mean, this seems logical. Why would the customer want to change his features midway while the application is being developed? Well, as you guys know that any application which is famous today, 90% of those applications are basically uh, has something related to internet. For example, Facebook is nothing without internet, Instagram is nothing without internet, WhatsApp is nothing without internet, Netflix is nothing without internet. All these applications, they basically work on the internet, right? And why are they working on the internet? Because there is a demand, right? So because if you talk about 10 years back, Netflix was not that famous. Why? Because internet was very expensive. Now with times, because internet is becoming very inexpensive in nature, right, Netflix has become very much relevant to the current generation. So as a businessman, I have to pick the right time and then launch my application, rather than, let's say, I think that Netflix is the the OTT platforms are the way to go. That is basically how the world is going to consume entertainment, or they are going to consume content. And I think about creating Netflix, and let's say the application takes around 10 years. My own application, it takes around 10 years to complete. Now, after 10 years, obviously, the relevance of that application will not be there. There will be 10 more inventions by the time 10 years is over. right? So I took a very long time. I said 10 years, but even 1 year for some businesses is pretty much crucial, right? Let's say you think about opening a website business today, right? And in that website business, you think that okay, I will be basically focusing more on let's say creating applications like Spotify, applications which are related to music, right? 6 months down the line, and when you approach the software company, they say okay, it will take around 8 or 9 months to complete. So you're like, okay, no problem. You take 8 to 9 months, but after 9 months, I need my application. So now what happens is once, let's say 3 months down the line, you realize that you discuss with your friends and you feel, you know what, we also should incorporate a lyrics feature in my application, in my music application, wherein if people are listening to the music, they should also be able to see the lyrics of that particular music file. Okay, so let's say that you think of this feature, you basically approach the software company who's creating your software, and they say, no, that cannot be done. Why? Because we are following a waterfall model. When we are done with this music app, only then we will start with creating the new feature. Until an application this is not done, I cannot make any changes to my team. There will be no changes in priority. We will first create whatever you told us before, whatever we discussed in the first place, and then we will pick up any new feature which has to be added. Okay, now this also might seem reasonable, but when you talk in terms of software, this could mean that there are a lot of things which you probably will have to discard, and there probably will have to be a lot of things which you again will have to write, right? So I mean, there are a lot of components in software which are written in a specific way, and if there is any new change which you want to incorporate in the software, that means changing the component altogether, right? But this kind of unproductivity is something which can come in waterfall model, wherein probably something which you want in your business then and there that cannot be incorporated, it takes a lot of time, right? And this was the main advantage with the waterfall model, right? So waterfall model was great, but the only problem is it took a lot of time, and by the time the software was over, it could be your customer has more requirements or modified requirements, which obviously you will be only be able to do once your software development release is done, right? Once your software is developed. But what is agile model? So agile model saw the disadvantages which basically waterfall model was facing, and what agile model said was, okay, so I see that the software itself is taking a lot of time to develop. Let's assume you gave me 150 requirements for your application. What I'm going to do is I'm going to take the 20 main uh, features that you want in your application, and I'm going to give you basically a prototype of the application which you can also give to your customers. Now when something like this happens, what basically happens is, if my application was initially taking 8 months to complete, for just creating 20 features, I can give my customer the application in the next 2 or 3 months. Now, when I do that, even my customer need not plan everything beforehand. What he can do is he can release the prototype application to his audience and then get the feedback and then decide what all other features he might want to add. Now, another great thing over here is because only 20 features were developed, the rest 130 features are still on the table to basically go ahead and tweak. So once you basically launch your prototype, you can then decide, okay, you know what, the customer feedback is coming that they probably do not want the lyrics application. So let's cancel that. Instead of that, let's put on, if they should have an option of watching the video of the music as well and stuff like that, right? So in this case, you're able to change the requirements, you're able to get the software a lot faster, and hence the agile model, right? So if I were to draw a chart between the two, you can see that the waterfall model basically said that once, if let's say the orange stage is requirements, once the requirements has been taken in, design stage has been done, implementation has been done, verification has been done, only then I can release my application. And this is the amount of time it used to take. But now with agile methodology, what I've done is that not only I'm releasing the software a lot faster. So if it was releasing over here. Now I have basically shortened the release life cycle to 1/3 of the time that it was taking earlier, given the condition that I will basically give you all the features which can make your application functional, and all the good to know features I will add later, and we can basically push it as a patch to your application. So this is the agile model. Agile, as the name suggests, it's more flexible in nature. The customer has more, more legroom for changing the requirements in case they want, while the application is being developed. Then there was one more methodology. So agile methodology was perfect. It solved the problem of the customer, but there was still a problem which existed within the team, which was about, since there was a lot of releases, so this red dot is basically a release which happened once the software was developed. Now in agile model, since there were features which were developed in patches, there was a lot of team meetings, and then there were a lot of planning which was going into getting the work done, right? So which again seemed a problem which we could fix by introducing a concept called eliminating waste. So in lean model, what we do is we follow the exact agile model, but what we do is we tell them that we are going to minimize human interaction. Instead of human interaction, we are going to make use of tools. We are going to make use of bug tracking tools. We are going to make use of feature tracking tools, so that human interaction is there at the minimum, and we don't have to waste time in discussing things which probably do not matter at the moment, right? So it's basically about setting up a mind frame that we have to save time, and with this conscious effort of saving time, in the end, when you see the whole project, how much time it took, there was a considerable reduce in time as well, right? So that is what the lean methodology was. So lean methodology has no difference with respect to the working of how agile used to work, but the only difference being that in this you had consciously thought about not investing more time, or not investing uh, or not wasting time as there might be, because we want to develop our software as fast as possible and with the highest quality. Okay, so guys, this was the waterfall, agile, and lean methodology. Now based on what kind of software you are developing, you could pick up a methodology. Now you might say, or you might think that I think in all the cases agile methodology is the best way forward, but that is not the case, right? Waterfall methodology is still being followed in some companies where the software which is being developed is very critical. Now what do I mean by critical? Let's say you're developing the software for an airplane. So if you're developing a software for the airplane, you would want the highest quality possible in that software, and obviously you will not want any kind of bugs in that application, right? So you do not care if it's going to take 1 year or 2 year to develop that kind of a software, but we want it at the highest quality possible. Why? Because it's a question about customer, it's a question about customer's life. It's a question about life and death, right? It's very critical in nature, and hence we do not want any mistake, and we are going to plan everything and tell you the requirements, and I don't want to disturb you guys and change my requirements. Go ahead and develop that software, and for that waterfall model is perfect. Why? Because in waterfall model you're not thinking about reducing time, you're not thinking about developing only the core features first. Let's say you go ahead and only develop the autopilot feature, but what about the navigation? What about what about probably the in-house lights, the AC conditioner? Could be any kind of software that you're developing, and let's say you leave those as software. So that is not something that you can do when you're basically developing an airplane software, right? Similarly, when you have mission critical software that you are developing, in that case, waterfall model is basically the best way to go. In softwares which are non-critical in nature, for example, if you're creating a social media application, or let's say you're creating an application for some internal work where you can probably go ahead and take bugs. It's okay to have bugs, because what you feel is that the main function of that software should just work, and rest other things are second or third priority. So in that case, probably agile methodology or lean methodology can be followed. For example, if you're creating a music application, or if you're creating a e-commerce application, it's okay, because you might have seen that if even if you're using Spotify, even if you're using Amazon, you might have encountered a 500 error. For example, when the great sale is happening, or when if my friends there in the US can relate to when Thanksgiving sales is there, companies like Walmart, companies like Amazon, companies like eBay, they basically run huge sales on their website. And sometimes so much traffic comes on their website that the website eventually crash. Now, when a website like this is crashing, it is still fine, right? It is still okay. But imagine if a bug comes in a airplane software, and because of that, the software or the airplane itself crashes. So we do not want anything like that. We do not want any kind of glitches in those scenarios, right? And hence, for those scenarios, waterfall model is perfect. In other non-critical applications, you can use agile and lean. Okay. Now I've explained you waterfall, agile, and lean, but why did we need DevOps, right? These three methodologies, they probably are touching everything which could be a problem while you're developing software. So why do we need a fourth methodology in place, which is basically called DevOps? Let's go ahead and understand. Okay, Santosh is saying difference between lean and agile. Well, as you can see, Santosh, in the diagram, there is only, if you compare the two diagrams, the only difference here is the question mark, right? And what is this question mark? Eliminating waste. So the only difference between agile and lean methodology is that in lean methodology, you always think about reducing or not wasting time in unnecessary meetings, and you always have the product in mind, and based on that, when you basically consciously put an effort for not wasting time. Now how can you not waste time? You cannot waste time by, instead of having meetings in a certain rooms, you can probably make use of softwares, right? Instead of probably maintaining everything in an Excel software, with respect to bugs, with respect to features, you can probably use uh, softwares like Trello, you can use softwares like Slack, right? So with this, a lot of time is reduced, and that is exactly the model behind lean methodology. Okay, is that clear, Santosh? All right, and I just want to give you, okay, all right, let's go ahead. So summarizing what the methodologies that we just discussed, they were intended at solving the problems between the customer and the software company. Okay. For example, when we talk about the waterfall model, it was aimed at coming up with a framework using which we can develop software. That was again something which solved the customer problem. That is, the customer wanted a software, and the company created a framework using which they can develop that software. Second thing was agile model. So that was again focused on customer, because he wanted a little bit of flexibility in terms of giving the features. And that's exactly what Agile did. Agile said, you know what, not only I will be incorporating changes with respect to your features, but I will be giving you a prototype beforehand itself to try out and give to your customers. That was the Agile methodology. Then came Lean methodology, which again had the purpose of reducing the software development time, right? Which is again aimed at customers. So all these methodologies that we discussed today were aimed at solving the problem between customers and the software company. Okay, so again, like I said, so why did we need DevOps in the picture when everything looks good? So the customer and the software are now very much gelled up and they can work together. So what was the problem? So the problem was within the company, right? So when you talk about the people who develop softwares, you can easily talk about the people who develop softwares into two teams. One are developers and testers, and the other are people who are from the operations team. That are people who basically make your code available on the servers from where the application will basically be hosted. Now the problem was that these developers and testers and operations guys had a problem with each other with respect to their work. Now what was the problem? Let's go ahead and understand. So guys, let's take a scenario to understand the problems that these guys are facing. So let's say I basically have two people in the team. I have the development team, and then I have something called as the operations team, which comprises of testers and system administrators who will be basically uploading the code. Okay. Now, a developer's job, like I said, is to basically follow what the manager is saying. If whatever requirements he is giving, those requirements have to be converted into a software application, and then it will be basically forwarded to the operations team, which comprises of the testers who are going to test the application. And once the test basically goes successful, they are basically forwarded to the system admins who basically go ahead and make their application available on the main server. Now the problem was, let's say I give a developer a task, okay, and his task is that whatever application I have right now on my server, let's say it is basically uh, missing a login page. So I asked my developer, hey, go ahead and create a login application for me, right? And once the application is done, just give it to the testing team, and if the testing team finds it fine, they will upload it on the server. So the developer is done with his work, and he basically gives it to the operations team to basically go ahead and run the code, test it for any errors, and let him know. And if no errors, then he can basically go ahead and upload the application on the main server. So once the developer basically gives the application to the operations guy, the operation guy basically realizes that whatever code the developer has given, it is not running on his system, right? Now, if it is not running on his system, there can be many reasons for it. It could be that the developer is having a certain software stack on his system, and that software stack has not been told to the tester, and because of that, the code is not running. Or it could be, there could be a million reasons why the code is not running, right? So what the tester does is he gives the code back to the developer and says, you know what, something is missing. This code is not actually running on my system, and if it is not running on my system, I actually cannot go ahead and pass it on to the system administrators to upload this code, right? Now the developer says that, you know what, I ran that code on my system, I can run it again in front of you. It is working perfectly fine. It is matching to the requirements of what the manager basically gave me, and I don't see any issues in that. You go ahead and check what is wrong with your system, because it's not my job to fix your system and make the code work over there, right? And the tester says it's not even my job to go ahead and fix my system up. If whatever is there on the production system, whatever softwares are there on the production system, I have the same softwares on my system, right? So if that code is not running on the tester system, obviously it will not run on the production system as well. So it is not my responsibility to take care of what is wrong in your code. You go ahead and figure out. Now, these were the kind of dialogues which were discussed or which were exchanged between the teams which were a part of the technical team, right? And because of this, a lot of time was wasted, right? And again, our aim was to basically reduce time and produce the highest quality software possible, and that was not happening because of these fights between the developers and the testers. Okay, and this is exactly what DevOps is, guys. So DevOps, as you can see, it's basically a mixture of two words, that is the development team and the operations team. So operations team basically have people which are system administrators and testers, and the development team has the people who have the uh, developers who basically code the application. Now, our aim was to make these two teams come together in order to not only waste time, but to also make the application basically, or make or develop the application faster. Okay, so what are the different ways where you think you can solve this problem? One way is by human interaction. You make everyone understand that, you know what, these are your roles and responsibilities, these are your roles and responsibilities, and probably this method can help, right, wherein the clashes can be reduced. But this is not a permanent solution, because if they are interacting and if their work is suffering each other's work, then there'll always be a clash. So to fix this, we basically came up with a methodology where we will basically make use of softwares. So what was DevOps? DevOps was basically a methodology which solved the problem between the development and the operations team. And if you were to compare when you introduced DevOps, what were the different kind of things that you saw? So in traditional IT, where DevOps was not followed, the team was very much less productive. With while you're using DevOps, it became very much productive. In traditional IT, the team was skill centric because if I have a team, that team will only probably have one expertise, probably in WordPress or in C or in C++ or in Python. Whatever my stack is, only that stack my team could work on. But with DevOps, now you have options where you can basically create a stack of multiple applications. You can have Node.js as well, you can have Python Django as well, you can have WordPress as well, which all are working for one particular application. And hence, even the team now is basically not skill centric, but more general in nature, right? In traditional IT, more time was invested in planning, but in DevOps, no or least time is invested in planning because all the work can now be managed via softwares. And finally, in traditional IT, if you decide a deadline, it was very difficult to meet the deadline. But when you're using DevOps, because there is no uncertainty now, the ease of attaining a deadline is more. Okay, so this was the differences between traditional IT versus DevOps. And now let's answer the $1,000,000 question, that what exactly is DevOps? Okay, so let's go ahead and understand that. So what is DevOps? So guys, DevOps is basically a methodology which aims at solving the differences between the development team and the operations team. And that methodology basically makes use a lot of softwares, and those softwares are implemented in a way which basically minimizes the effort, the human effort, and at the same time it solves the problem of the different kind of clashes which the development and testers were getting. For example, now there will be no question of the code running on one system and not running on the other system, right? There will be no question of not being able to update 100 systems at once. So if before these DevOps tools were not there, this was all done manually, right? But with now being DevOps more famous, right? If you are dealing with 1,000 of pair or a 2,000 pair of servers, all these servers can be updated with the click of a button on a particular software stack, right? No human involvement is required, right? And even let's say I am a developer, right? And I want my code to go ahead and be tested. So the tester will now not manually test it. There will be automatic test suites which will be created. And once the code is basically deployed, my testing team, the automated test suite will be created by them. These automated test suites will be run against the code, and a feedback will be given via email to my developer within seconds. So earlier, if you were to mail some guy and to see whether that guy is available in office or not, and then get the feedback, it used to take around 2 to 3 hours, right, in a working day. But with this, you started getting feedbacks in minutes, and not only one developer. Any developer in my team can go ahead and commit his code and see whether that code is working or not, right? So these kind of automations, these kind of softwares, when you basically uh, implement using the DevOps methodology, it's basic, or using the methodology that we're basically going to go ahead and develop, it's called DevOps. Okay, so what is that methodology, or what is that life cycle that basically has to be followed in order for different tools to come together and achieve a goal? Well, that life cycle looks something like this. Okay, so these are basically the stages that we discussed a while ago. That first, what you do is you plan whatever you have to do, then you code your way in, right? Then there is one more technical term over here which is called build. So once you code an application, what happens is, for example, if you would have used anything on Windows, you will see that every application which can run has an extension of .exe file, exe, right? So if you run any application with the .exe file, it straight away goes ahead and runs. So somebody must have developed that application on the first place, right? So they would have written the code, and then that code was converted into an exe file. So this conversion of code into an executable file is basically called the build process. So once you plan what application you have to develop, then you code that application, then you build that application, and once the build is complete, you give this build to a team of testers to test it. Once the testing has been done, it basically gets released to the customer, and once the customer has been given the software, he checks if everything is good. If everything is good, he basically goes ahead and deploys it to all his stakeholders, and once it has been deployed, it is basically then monitored and operated, in the sense it is basically used, and then you start monitoring it for any kind of feedbacks that you get from the customer, and then those feedbacks are basically again implemented back on the application while the maintenance stage is going on. So this is the DevOps methodology. It's almost the same, but let's see what are the differences over here that we can see. So the plan and code stage is called something called as continuous development. The build and test stage is basically something called as continuous testing. The release and deploy stage is something called as continuous deployment, and the operate and monitor stage is something called as continuous monitoring. So what is continuous development, continuous testing, continuous deployment, and continuous monitoring? Let's go ahead and understand. And all these stages are basically implemented using a stage called continuous integration. Okay, so this is the heart of DevOps, and this you will actually understand when we basically go along. So now let's typically see how a developer basically works when a DevOps engineer is a part of the team, and he basically creates a pipeline for him, or he basically creates a method for him through which he can put the code or push the code or submit the code and get instant feedback if required. So this is, let's assume, the developer, and what he does is first he basically develops the code, right? So once the code has been developed, he basically pushes it onto a version control system. Just give me one moment. Okay, so this is the developer. He basically goes ahead and develops the code, and this code is basically pushed onto a version control system. Now, what is a version control system? Version control system is basically a software where basically code can be pushed, and then the code over there is automatically maintained in different versions. So let's say if you are done with your code today and you push it, tomorrow you make some modification to the code, both the code that I did yesterday and the modification will be stored on a software, so that if tomorrow somebody has to see, let's say in June we did a release which was working perfectly fine, but now we are working on the application and something is not working correctly. So what we want to do is we want to refer the code that we had in June. So version control system basically helps us to see the history of the code, who edited what line was edited, even what alphabet was edited can be recorded by the version control system. And this is pretty useful, right? So the developer basically pushes his code to to a tool called a version control system. And once the code is pushed to the version control system, what happens is there is a tool called a continuous integration tool. This tool basically goes ahead and waits for any kind of code change which is going to happen on the version control system. So the moment the developer basically pushes the code, the continuous integration software, it automatically gets to know, okay, so there is some change. Let's pull that change and deploy it on the testing server. So what the continuous integration software does is it picks up the software which the developer just pushed, and basically it puts it on the testing server. Then once this continuous integration server puts the code on the testing server, it is tested against the automated test cases which are developed by the testers. And if let's say there is any error which basically comes in, right, the feedback for that error is given back to the developer, saying that in your code at this particular line, this is the error that you are getting. Please go ahead and resolve. Once the developer has resolved it, he can again push it back to the version control system. Again, it will be picked up by the continuous integration server. Again, it will be pushed on to the testing server. It will be tested. The feedback for that test will be given to the developer. If let's say it is a pass, let's say the test cases have given that everything in this particular code is working perfectly fine. The continuous integration server can also sense that, and once it has sensed it, it can basically deploy it on the production servers as well. What are production servers? If you're using facebook.com today, that is the facebook.com which is there on the production server. If let's say you are a Facebook employee, and let's say within the company they basically give out the features to test, right? So those test features that you will be able to access, that will be from the testing server. Okay, so testing server is something which is internal to the company. A server which basically has prototype applications is what testing server is. Production server is when everything is ready and you want to make it available to the world, right? So even on production server, your software can basically push, given it has passed all the test cases. Now you will ask, okay, I understand this is how DevOps works. So what is my job over here when you will become a DevOps engineer? Your job is to basically configure all these softwares and make them work in a way so that they are completely automated. Okay, this is the job of a DevOps engineer. A DevOps engineer basically goes ahead, understands the product, understands how the team works, and develops a pipeline, develops an architecture. This is a sample architecture that I showed you. Develops an architecture which basically will help the developers, the testers, and the operation team to work with minimum hindrance and maximum productivity possible. So guys, this is what DevOps is. This is in a nutshell what DevOps is. Now moving forward, we will be understanding each and every stage. We will be understanding each and every software which basically helps in creating this pipeline, and then go ahead and create a pipeline ourselves as well. This is what the whole course is about. Okay, so it is important that you understand what I just told you, because if you're not able to understand that, you will not understand what we are doing in the future. Okay, Balan says, I heard another term which is called SRE. What is the difference between DevOps and SRE? Balan, SRE, as far as I know, is a site reliability engineer. It's a profile. DevOps is basically a methodology. So a site reliability engineer is basically sort of an administrator who takes care of all the production and the testing servers, all the security which is required for the servers, etc. So site reliability engineer is not exactly a DevOps engineer. He's a person who basically handles, the deployments. Let's say you have a architecture on cloud, so that guy is responsible for handling that architecture with respect to not letting anything go down or deploying stuff, right? But DevOps is a completely different beast. It's about helping or giving a direction to the technical team, and helping them or enabling them to work in the most productive manner possible. Balance is, as the SRE also seems a hottie of it. Yes, absolutely, Balance. It's basically a very good profile, but it's different from what DevOps is. It's completely different. So this is how basically the methodology looks like for DevOps. Okay. So now let's talk about the tools that you're going to learn while you're basically learning DevOps. So for continuous development, which basically is about planning and coding, right? You will be learning a software called Git, right? So there are a lot of softwares out there which can help you do version control. Git and SVN are among one of them, right? So we will be making use of Git. We will be understanding what Git is. We will be understanding the different commands which are there in Git, using which you can go ahead and push code, or you can maintain code, or you can see code, how it works, right? Then you have something called as continuous integration. Continuous integration is the most important tool among all the tools in DevOps, because this tool is going to help you automate almost everything in DevOps, from For example, your version control tool is good at versioning, right? And your deployment tool, which you're going to discuss in a few moments, is good at deploying. But who connects this software, who can version software, and which can deploy software? That's a continuous integration tool, right? And for continuous integration, we are basically going to go ahead and learn Jenkins. Then we have something called as continuous deployment. So continuous deployment basically helps you to deploy code. And for this, we will be learning tools like Puppet. We will be learning tools like Ansible, Docker, which basically helps you in deploying the code, right? So we'll be learning about those things. Then we have something called as continuous testing. Continuous testing, yet again, is basically going to help you guys uh, to test software automatically, right? Automated test cases. And that again is something which we are going to learn in this course, which is basically going to be with the help of Selenium, right? And then we are going to have something called as continuous monitoring. So this is going to be a monitoring server, which is going to monitor servers, which is going to monitor users who are basically making use of your application, who are sharing the feedback for any software which is not running, for any feature which is not working. So this monitoring software is going to log all those things, okay? And then it is basically going to forward it to the stakeholder. And it's okay. So one more thing, why do you think you have continuous in front of everything? Very important question. And I think I've given the answer, or probably I'm not given the answer to this as well, but I want to see like uh, how much of you can basically go ahead and guess. Let's put the word as guess. How many of you think uh, all these life cycle stages in DevOps are called continuous in nature? Can somebody explain? Srinath says, could you list out the tools? I'll do that. I'll do that, Srinath. Just wait a minute. But answer this question for me, guys. Why do you think there is a continuous keyword in front of every stage over here? Please explain that. Anybody who can explain? If you want, I can unmute you as well. If you want, you just have to say it in the question box. Why do you think this continuous word is written over here? Santosh says it does continuously, or IT does continuously. Okay. Balance says it is an agile method that have periodic releases, so continuously these DevOps are needed. Okay. Others, what do you think? Good job, Santosh and Balan. I think you guys are a little close to what the actual answer is. Emmanuel saying, Daniel say, I think it's a lean word. Okay, Emmanuel. All right. Tina says for feedback of all. Okay. Sayed says because it continues from start to end and loops until it's right. Absolutely, Sayed. You are bang on. Emmanuel says for continuous improvement. Okay. Okay. So let me give you the answer. I think Sayed gave the correct answer, the correct explanation to why continuous is there. So guys, see over here. So let's say you have a team of 50 developers. Okay. Each developer is doing or pushing code at some point in time to your version control system, which at some point in time, at any point in time, continuous integration server is picking up, it is deploying it, testing it, any problem is coming, giving the feedback to the developer. So your tools are continuously being developed and are being pushed to the version control system. It is being continuously being integrated, it is continuously being deployed, and it is continuously being tested and being monitored. And once the code reaches back to the developer again pushes it onto the version control system, which is again integrated and deployed and tested with the feedback being again given. So you can see this is a life cycle which goes on and on. So even if the product is, let's say, finished, right, there will always be maintenance phase, right? So there will always, so you never see, once a product is developed, the development team is never sitting empty. They always have work in hand. So how do they get this, all this work? They get all this work from the continuous monitoring stage. The feedbacks, the bugs, the new feature requests, everything comes from the continuous monitoring stage, right? And since this happens, like Sayed pointed out, in an infinite fashion, right? It's basically called continuous. And everything is continuous, continuous developing, continuous integration, continuous deployment, continuous testing, right? So continuous monitoring. So everything is continuous because it is never going to stop. Okay, so that's what is the logic behind the continuous keyword. Okay, so in continuous monitoring, like I said, it's absolutely, it's continuously monitoring whatever feedbacks are coming in. And for this course, we are basically going to go ahead and learn Nagios for continuous monitoring. Okay, now to answer Srinath's question where he was asking the different tool list that we basically are going to teach you guys. So these are the tools, guys. So for continuous development, we are going to teach you Git. For continuous integration, we are going to teach you Jenkins. For continuous deployment, we are going to teach you Docker, and we're going to teach you Puppet and Ansible. For continuous testing, we're going to teach you Selenium. For continuous monitoring, we are going to teach you Nagios. And finally, there is one more tool that we have added, which is called Terraform, which is infrastructure as a code, which is a very new concept and is asked in every DevOps interview these days. That is also something that we are going to cover in the course from module 2 onwards. This was an introduction to DevOps. So with this, you should have a fair idea about what DevOps is, why it is implemented. So one of the confusions that most people have is, okay, so let me ask that confusion itself. Okay, so let me create one question for you guys, and let's see if you guys can answer it. So this will again check your basics. Let's go ahead and answer this question. 80% have voted, 20% are left. It's okay to be wrong, guys. It's totally fine. Please go ahead and vote. These are the results that guys have given. So guys, the answer is DevOps is basically a methodology. Okay, it's not a tool. DevOps is a methodology which tells us how we should basically go ahead and implement tools in a certain way so that we can achieve the true autonomous stage wherein uh, most of the tasks will be automated, and the problem that we initially had between the development and the operations team should not be there, and whatever is required should be managed by the software automatically. So this was the thinking behind DevOps, right? And various tools, it's not only one tool, various tools are basically used in order to implement the DevOps methodology. So it's not like in continuous monitoring, we will only be using Nagios. We can use such software like ELK as well. There are multiple monitoring tools, but we are not sticking to any tool, right? What we are saying is that if you understand DevOps and if you learn any tool which is related to the lifecycle stages that we have discussed, you can go ahead and implement it because you understand uh, what the intent behind implementing DevOps is. So obviously the tools that you will be picking, the work that you will be doing will always be behind that intent, which is to automate as many tasks as possible so that there is no point of uh, problem between developers and the operations team with respect to human errors. There should be nothing of that sort. This not only is going to improve productivity, but also at the same time it is going to create a more healthy work culture. Okay, this is what DevOps is, and I'm very happy 95% of you guys gave the correct answer. Great, awesome. And this is actually the most confusing things for people as well when they first hear about DevOps, right? Because most of the people, when they know very little about DevOps, what they say is that DevOps is a tool. It's never a tool. It's basically a methodology, and this methodology basically has told you different stages. Now, in these stages, you can fit any kind of tool that you want. And obviously, there are multiple tools which basically have to be used.